Okay, this is the first hour of our class, data science for cybersecurity, and for the very first hour, we will talk about security management, and that is the only hour we talk about management problems, because after that, the rest of the class will be discussing algorithms, tools, or security data set, or any advanced method to analyze security related data. So that is the only hour we talk about security management. Okay, so here is the definition of security management provided by Colab AI. I think that is quite makes sense. So I passed the result from the Colab AI. It says security management is a process. So management is a kind of process that it is never be a single event or some actions. Once you've done that kind of action and everything is good. No, security is kind of a management, and security is some kind of process. You have to collect information, you have to analyze those informations, and you have to respond to that, and then so on and so forth, so on and so forth. So it is kind of a process. So what you should do in such kind of process, in this definition, it says identifying security risks, assessing security risks, and mitigating them. So first, you have to deploy some tools, some algorithms, some other knowledge base, some human expert help you to identify what kind of security risk in your organization. So that's the first step. And after identifying such kind of security risks, and then you do risk assessment. That means you have to quantify the risks, okay, by using, for example, how severe it could be if it happens, and what is the probability of such kind of security risks that occurs in your organization. And after that, you know, okay, there are certain different types of risks, and the impact of the risk and the probability of this risk, and you have to make a plan. Which risk is more important in your organization, and then you take some action to mitigating such kind of risk. So that is a kind of a process to do security management. And there's important things right here. It says to an organization's asset. Maybe in 20 years ago, in your organization, the most important things is about maybe it is the equipment, the PC or the hard drive that your department have, and you say that is the important asset of this of your organization. But nowadays, usually we don't think that kind of a physical asset is not that important in nowadays. So currently, when we talk about asset and security management, we talk about data asset, because data is the most important thing to run a company or to run a business. For example, for Yahoo or for a company like Microsoft, of course the building is very important, but even if the building is gone, okay, they can buy another building, okay. But for such kind of high-tech companies, if the data, okay, especially business data, user data, or any cloud data database, if those data asset is gone, and then the whole business is gone. So currently, when we talk about asset in current organization, we talk about data asset. So the security management is a process to help us to identifying, assessing, and mitigating a lot of different security risks to the data assets that an organization own. And if you want to do such kind of things, you have to implement a lot of different security policies, procedures, and technologies, hardware, software, and policies, rules, and use such kind of technologies or rules to help you to protect against the unauthorized access, use, disclosure, disruption, modification, and destruction of your data asset. Because that is the most important thing you need to protect in your organization, which is the data. And the whole process, there are several different concepts in the security management. So you need to first take a look at these few following steps, okay? And we will talk about some important things right here, okay? So before we continue, we need to know what is the definition of, for example, safe and security and or secure. In Mandarin, the translation of safe and security is the same word in Mandarin, but it is quite different in English. So for safe, when we talk about safe, that means it is some kind of feelings in your mind, right? Because we usually say, okay, please go home safe, right? We never say please go home security or go home secure. Safe means some kind of feelings in your mind. So that is more metaphysics. Okay, so in every security textbook, when we talk about safe, in very first page they will talk about CIA tribe. That means confidentiality, integrity, and availability. And this kind of safe in an organization, basically the high-level manager, for example, the CEO or the CSO or manager, general manager, they need to provide or they need to make a plan to make their company or their product, their services to be safe from the perspective of offering services to the customer. So basically, they may maybe they have a commercial on the TV and says, okay, we provide some services or some product to the consumer, and if you use our product or our services, and I guarantee, for example, the data is with confidentiality, integrity, and availability. The definition of CIA confidential means they majorly design and prevent sensitive information from unauthorized access attempts. So, for example, if you store your document in our cloud-based database, and I guarantee your data, your sensitive information will never be retrieved by unauthorized users, because I use some complex cryptography to encrypt your data, so no one can access that. Okay, so the high level managers, the general managers, they have to provide such kind of guarantee to their customers, so their customer feels safe to use the services provided by your company. And also the integrity is the same thing. It involves maintaining the consistency, accuracy, and trustworthiness of data over the entire life cycle. That means if you store your data or you store your user profile in our database, in our services, and no other hackers or can manipulate your data. So your data will be has consistencies and accuracy and trustworthy of data. So that is also the high level managers need to give such kind of guarantee to the customer. Okay, that is integrity. And availability means the information should be consistent and readily accessible for the authorized parties, which is the authorized customer. Every time you want to use your profile, your data, it is ready for you to access those data. And for example, some company or some database company or some cloud-based storage company, they say, okay, you have 99.9999% of time you can access your data, and your data is quite has confidentiality and integrity. So that is CIA, okay, which means you can provide some kind of guarantee and make your customer feel safe to use your service or your product. Okay, so that is the first definition, safe. And the second one is security. In English, the definition is quite different. Basically, it means security control. There are three different concepts of security control, which is AAA, authentication, authorization, and accounting. And usually, for the boss, okay, for the high level manager, they simply just provide some kind of concept to their customer to feel, for CIA to feel safe. But actually, those bosses does not know how to implement confidentiality, integrity, and availability in their systems by hardware or software. So security, okay, this level of security is managed by middle level managers. They know a lot of different tools, technologies, or they know how to establish security rules or policy to implement AAA so that CIA can be fulfilled. The AAA is authentication, authorization, and accounting. So the authentication is quite simple. That is verifying the claim of identity, which means who are you. For example, if you have an email account and you log into your, for example, Gmail, and you have to provide password and ID to prove you are you, right? So that is authentication. And after authentication, you have the system may have to perform some authorization process. Not only know who are you, but also know what action you can do, what action is permitted after they know who are you. So the second question is, what can you do on the system? For example, if in a company, okay, if there is a database, so the database administrator can access the database, right? But for general programmer in a company, it can only query the database. It cannot delete any tables or any entries. So they need authentication tools or a mechanism to specify who is the administrator and who is the general programmer. And after that, they define what actions can the database administrator can do to the database, and also to identify to determine what action can be done by the general programmer in this organization to use the database. So that is authorization. And accounting means it is a process that keeps tracking of users' activity while they attach to a system. Okay, that means it has to log every actions in the system. So if there is any security incident, for example, some hacker breaks into your website and modify your website web pages, the web server and the database server and some other server need to record everything that the hackers done, even if the hackers trying to delete the traces of what he have done to the website. So that is accounting. If there's any security accident happens, we know where we can find the auditing or auditing logs, and to do certain kind of security forensics. So for the middle manager, they have to establish certain security control that including software and hardware and policies to make sure we know who are you and what can you do, and everything you do to the system is recorded in a very secure place, so we can check it out. Okay, so after we have such kind of security control, then we can fulfill the CIA triad: confidentiality and integrity and availability. Okay, so let's take a look at another concept, which is assurance. Again, it has three different important things need to do, including auditing, testing, and monitoring. So I think I can give you a very interesting example in our real life, which is COVID-19. When we have COVID-19, when we quarantine in COVID-19 at the campus, okay, usually our principal, okay, which is the highest manager in our university, right? So he has to guarantee certain kind of safe to the students and their parents. Say, okay, we have certain security control which has applied in our campus, and we make sure the student in studying in the university will be safe, right? So that is what the principal, the university principal, need to do. They have to provide some kind of safety. Okay, but how actually such kind of safety is implemented? We need a middle level manager, which establish certain security control. For example, when you enter the campus, you have to scan your student ID. When you in the classroom, you have to wear a mask, something like that. That is security control made by the middle level manager. Okay, but what exactly assurance is? Even if the top level manager they want to achieve certain kind of safety, and even if the middle level manager they establish certain security control, but sometimes students just don't want to comply with those kind of security control. They do not want to follow those rules. So sometimes students violate those security control. So assurance is another kind of a mechanism that can help the middle level manager to make sure the established security controls are implemented accurately. No one will break such kind of rules, including auditing, testing, and monitoring. So again, take the COVID-19 for example. Maybe those managers need to set up some cameras at the campus or the campus gate or classroom. They need to monitor if the student indeed wearing mask. If not, then maybe they send certain alert to the manager, and they can again go to the classroom and make sure every student wears masks in the classroom. So established security control is one thing, but you can implement it and accurately implement those security control. That belongs to assurance. You need some monitoring systems, testing system, and auditing systems. And again, in cybersecurity, when we for example, in the organization, we also need to set up a lot of monitoring systems to monitor for example, the users' actions, monitor the network traffics, monitor the incoming emails or something like that. And every time we set up the monitor, we need to check the subject we monitored to see if it violates those security control rules, policies, or standards. So that is the things auditor need to do. And the testing right here is a little bit different. That means if you have some software, if you have some systems, you need to test the systems and or the software at the first place, so that makes sure it is what you want. It is the software what you want. So make sure you have done auditing, testing, and monitoring in your assurance mechanism, so that your security control will be accurately implemented. And after that, your boss can say, okay, we provide certain kind of safe in our services or our product. So that is the relationship between safe, security, and assurance. Okay, and we have talked about assets. So currently, data asset is the most important asset we need to pay attention to. So including the files, database, document, website, user profile, the purchase records for example for Amazon. Those are important data assets. Okay, because they are so valuable, so we need to protect it. But if you want to protect your data asset, the first thing you need to do is the inventory management. That means you have to make sure how many different data sets does the company have, and where are they? Are they in database or in the cloud, or do they have any copies or replica? Something like that. You have to do inventory management. So maybe it takes you 2 or 3 weeks to perform inventory management. Okay, so that you know how many different data sets you have. And after that, okay, we do after that we have data protection. And here we have 3 different scenarios to protect the data: the data in transit, the data in use, and the data at rest. The data in transit means when the data move from one computer to another, or from one software to another software, you have to make sure the data is safe. So basically, most of the time, for example, when you download your profile, when you download your purchasing record from Amazon or from Google, and they have to make sure the data is encrypted, so that even if the data is lost or taken by the hackers, the data is still safe. Okay, so data in transit. Data in use, that means maybe the data is in database, and some you use certain software to access the data, so data is in use. So make sure you have a proper authentication and authorization mechanism applied on the database, so that the data will be safe, will not be accessed by unauthorized users. And at rest means on the disk, on the hard disk. Okay, so make sure your hard disk is encrypted, or your database is encrypted, and make sure when you your data as a replica and safely stored in somewhere. Okay, so that is data at rest. That's the 3 different scenarios when we talk about data protection. Okay, and here I think that is important matrix right here. When we talk about risk, okay, 2 dimensions. One is probability, and another is impact. Okay, so that means if there are certain security risks in your organization, and you have to when you do inventory management, you have to do risk assessment, right? And the risk assessment, you have to identify such kind of risk and what is the probability of such kind of risk: rare, unlikely, possible, likely, certain. Okay, for example, receiving a spam mail, maybe the probability is likely or certain, but an insider to for example, an insider to a store steal your database, maybe such kind of probability is unlikely or rare. So different security incident, okay, they have different probability. And the other dimension is impact. So you have to identify what kind of impact it will be if such kind of security incident, such kind of risk happens. Negligible, marginal, or some other even severe impact. So let's, for example, let's take a look at maybe this one, like spam mail, right? Spam mail occurs quite often, so maybe the probability is likely. So we receive a lot of spam mail every day, but the impact of spam mail is nearly nothing. So maybe that is the risk. It is the medium risk in the risk matrix. Okay. For example, this one. Nuclear planet. If there's some incident in nuclear planet, then that is quite rare because they may have some certain security control and quite safe mechanism to make sure the nuclear plant will not explode, right? So that is rare. But if it indeed happens, the impact will be very, 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 very severe. So basically, when we talk about risk, you have to make sure what risk that you are talking about, what color in this risk matrix it is, and you can rank the risk by using these metrics. And of course, for some incident which belongs to very high, then you have to prioritize such kind to solve such kind of security risk, right? Okay, but we need to talk about the cost. Sometimes solving very high risk, okay, very high risk, may be costly, and sometimes even you want to solve a medium or a low risk, they still need to cost a lot of money. So from the perspective of management, okay, your boss always evaluate how much money he can spend on different level of risk. So if you really need to solve some kind of important security risks, you think that is quite important, it needs to be solved immediately. Such kind of problems should belong to very high, so that your boss will give you some money to solve such kind of risk right now. But if a risk, okay, it belongs to low or even medium, maybe your boss will not give you money to solve such kind of things. For example, if you want to deal with the spam mail problem and you need maybe 5 million, New Taiwan dollar, 5 million New Taiwan dollar to buy a firewall or application firewall to block all the spam mail entering your organization. But maybe your boss believe spam mail problem is a low risk problem, so maybe he will not give you money to do such kind of to buy such kind of expensive firewall to solve spam mail risk. Okay, so it's related to money. Okay, so after you have such kind of risk, you have several different ways to deal with them, including spend money to solve such kind of risk. And here we talk about tangible and intangible. That means loss. For example, if you have a e-commerce website And sometimes your website will be attacked by the hackers. And every time the hackers um, shut down your website, it may cost you, for example, 5 million New Taiwan dollars, because your website is unavailable for your customer to access, right? So every time, and you can, for example, in 1 year, okay, 335 days, okay, the probability of your website being attacked is, for example, 3%, uh, 1%, 1%. Okay, so on average, okay, there will be 3.6 day per year, right? 3.6 day per year, your website will be attacked, and every time it costs you $5 million. So on the average, okay, your loss will be over 50 million New Taiwan dollars, right? So that is how we count loss. But if your website indeed has such kind of shutdown incident, and maybe your user or your customer believe that your company is not safe, okay, we double quote, it is not a safe company. So maybe you suffer from some intangible loss because they don't trust you. They don't trust your website because your website has a lot of security incident, right? So that is how you calculate your loss, okay? And then, for example, if you're your IT manager, you can use this number. Okay, for every year, okay, on the average, we lost 50 million New Taiwan dollars because of the shutdown of the website, because hackers attack our website. So I need some money, for example, 10 million to solve such kind of problem. And maybe that, because 10 million is less than 50 million, right? So maybe your boss believe, okay, that is quite worthy to do such kind of investment to solve the problem of being attacked by the hackers, right? So this is how we calculate loss and cost and risk. Okay, so again, there are several different approach to deal with the risks. For example, the first one is risk avoidance. That means try to eliminate such kind of a risk. But sometimes, even if you buy a very powerful firewall or spam mail detector, there is always some very small amount of spam mail or attacks will pass through your expensive firewall or email spam mail detector. So sometimes, okay, we simply just mitigate the risk, not eliminate the risk. Okay, and the third thing is quite interesting, is that we accept a certain kind of risk because it might be belongs to the low category in the risk matrix. That we simply just ignore such kind of risk because it is a risk, right? But it is not that important for us to deal with such kind of a risk immediately. We can just simply accept the risk. Okay, and there is another kind of things to deal with the risk. For example, we can transfer the risk. For example, if we have a database, but we lack of IT crew to help us to protect the database. So basically, we can, for example, store our data in cloud-based database, and we pay money to some more advanced, more professional a database company to help us to store those data. So we believe they have better mechanism to protect our data. But if there's anything wrong with our database on the cloud, they have to pay us back, right? So that is the concept of insurance, right? So that is the concept of some different interesting things, including SAFE, CIA, security, AAA, and assurance, and the risk. We discussed something about the risk, right? So so here, security management, including several different processes, including the risk assessment, as I mentioned before, the policy management, the middle level manager, they need to establish certain procedures or policies and try to mitigate the risk. Okay, if everyone follow the rules, the policy, the standard, okay, they establish, and the company will become more safe, right? And also including implement need some software and hardware to hardware to implement in the security technology such as firewall, insurance detection systems, encryption decryption algorithms to protect data against the threat. And the fourth thing is more important, is very important as well, is the employee education. Because for example, if you want to deal with the spam mail problem, you can buy a 5 million expensive firewall to block all the spam mail. But also you can hold some security education meetings. So educate employee, which is much more cheaper than buying an expensive machine, right? So education is very important too. And the next one is incident response. So as we mentioned before, you have to set up several monitors and to do auditing to check if any policies or any rules, any standards are violated, right? So once those rules are violated, you have to do some incident response, send an email or shut down the database or block every network traffic, something like that. Right? You cannot just that security incident happens and do nothing. So you need some incident response plan. Okay. And again, I said, including in the incident response, you need some monitoring process and you need the auditing process to continuous monitoring the security of organizations' assets and review those policies and make sure they are effective, which is assurance, which I talk about. Right. So that is the very first part of the security management. We only demonstrate some important concept in this section, okay? But that is the only thing we have, okay? So that is, and if you are interested in security management, there are several international standards such as ISO 27001, okay? And you can take that is a certification. You can take the exam and get the certification, and they will teach you how to make your organization to be safer. Okay, so there are a lot of different standards, policies, and rules that help your company to be much more safe than old times. Okay, so the second topic what I like to talk about in M01 is the malicious software. Okay, I draw this figure. Okay, the black dot is the malicious software in that year, and the blue dot is the technology or some software invented in that year. So we can see that along with the timeline, okay, for example, here we have the very first IBM PC or Apple II, which is also a computer, right? After we have such kind of modern computers, okay, then there will be virus. Some hackers made some malicious software for IBM PC and for Apple II, right? For example, right here, after web is popular, we have some web-based or internet-based malicious software. Okay, for example, here, after we have Office, Microsoft Office 95, 97, Microsoft Office, it includes very important, we say important things, which is called macro. That means you can write program in your Excel file or in your Word file. So after that, hacker, okay, they have a macro malicious software, okay, and so on and so forth. You can see that after time we have some new technologies. For example, Nessus. Nessus is the first smartphone made by Google. After we have such new technologies, and after that, the malicious software will target on such new technologies. So, for example, after 2010, after we have smartphone, there will be a lot of Android malicious software has been developed by the hackers trying to steal our personal information in our smartphone. So basically, the timeline is quite hackers will try to invade some new technologies, because every time we have new technology, we don't know what exactly it is. So we simply just use those technology, for example, the smartphone. And we don't know how to protect smartphone. Just as in 1980s, when we have personal computer, we don't know how to protect personal computers. So that is the chance, that is the opportunity for the hackers to invade our personal computer. Something like that. So currently what we have IoT device, right? We have IoT device. We have a smart home. We have cloud computing. We have artificial intelligence services. And that is hackers trying to invade in current days. IoT device, AI algorithm, and the cloud. Okay, so that is just a big picture of the timeline. Okay, so when we talk about malicious software, okay, we have several different things need to discuss. Okay, software is malicious software is a software that designed to damage or disrupt the computer system. And there's a concept called a malware family, because a hacker may write some malicious program and compile it and send it to the internet. So try to invade victims, right? But after few days, okay, security companies such as antivirus engine vendor like Tremacro, like Microsoft, like Kaspersky, those security company will analyze the malware itself and try to produce the signature of the malware, so that you can use antivirus software to detect the malware. But after that, the hackers will try to manipulate or try to modify its code and generate new malware samples, and so on and so forth, so on and so forth. So basically, in current days, malware is not only a single, most of the time, not a single malware sample. They will some of the malware will belong to certain malware family because the hackers continuously modify its code and compile the code and send it to the internet. So basically, there's a concept called malware family. The malware in the same family, they share similar characteristics. For example, their function name, their functionality, their target. For example, they try to steal your information, steal your email, steal your credit card number, something like that. So we have a concept called malware family. And the malware in the family is what we call malware variant. Okay? So they share maybe they share the same functionality, the same target, the same attack vector to invade into a PC or to a Android smartphone. Okay, the infection attack is okay. So here we can see that there are several different types of malware, including virus, worms, something like that. Basically, the name is meaningful. So when we talk about virus, that means that program will self-replicating, just like the real virus. Okay, they will attach themselves to other programs, just as the real virus will attach itself to a cell. Okay, so we have some malware which it belongs to virus. Their characteristics is self-replicating and attach themselves to other program. So that is virus. And for worm, very similar to virus, they also do self-replicating, but they also do self-propagation. They will propagate from one victim to another victim. Self-propagation without any human involvement. That is called worm, just like worm, the real worm. Okay, ransomware is a type of malware that encrypts your file so that you need to send some Bitcoin or critical currency to the hacker, so they will give you some program to unlock your encrypted file. Right? Spyware is a software that will collect your information in your PC, in your cell phone. For example, your browsing history, your keystroke, your password, something like that. Okay, that is spyware. Scareware is that a type of malware that displays fake security warnings and alert to trick the victim. Sometimes it says, okay, your cell phone has been hacked. Please send me some money. But actually, this is a fake information, fake warnings. Okay, rootkit is a little bit different. In our computer, okay, our operating system, operating system is protected by some mechanism, but the rootkit will not only attack your software but also attack your operating system and try to hide themselves in the operating system. Okay, so that is a very rough classification of different types of malware, but I think that's good enough for you to understand there are different types of malware. And I would like to show you this view graph that is interesting thing that I'd like to show you how internet worm propagate itself from one victim to another. Okay, so follow those steps. Okay, we have three different parties in this view graph. The left hand side is the attacker, the right hand side is the victim, and there is another one called website, which is Windows update.com. Okay, you don't have to know how the infected host or how the attacker get the very first file, which is msblast.exe. It is an executable file of the blast worm. Okay, somehow somebody execute it. Okay, so that is the first things. Okay, and step number 1, after the msblast.exe has been executed at the left-hand side, it creates a worm code, which is a process in the operating system. Okay, the purple one, that is the worm code. Okay, that is the main body of this this attack. Okay, and let's take a look at step number 2. The blaster worm code will establish a network connection to some other IP in the internet. That is, they randomly choose 20 IP addresses and connect to those IP addresses. Okay, and in early 2000, okay, for example, there are a lot of Windows XP and Windows 2000 machine on the internet, and basically most of them has the pink process, pink services, which is called RPC. It opens a port at TCP/135, which can accept services from accept requests from other machine. So basically, the blaster worm code will randomly select 20 IPs machines on the internet and try to connect to the vulnerable RPC services on the internet. That's step number 2. Okay, and in the meantime, step number 3, the blaster worm code will check the date. What time is it and what date it is? And if it matches certain predefined date and time, it will try to do some attack to the Windows update.com, trying to block the Windows update.com. So no one can get services from the Windows update.com. Okay, that is step number 3. And step number 4, after the blaster worm code at left-hand side connected to the right-hand side, the vulnerable RPC services, and then the blaster worm code will send a specific packet to the RPC service. Okay, but that specific packet will trigger the vulnerability of the RPC service. So step 4.1, after the vulnerable RPC service get the RPC request from left-hand side, it causes a vulnerability, and it is called buffer overflow. That means the purple part will be crashed. It's crashed. Okay, that's the 4.1. But before it really crashed, okay, the hacker, the exploit code right here, will launch another process at the victim, which is the purple one, which is called shell code. And the shell code will open a TCP socket at 4444. Okay, after that, then the blaster worm code at the left-hand side will talk to the shell code at the right-hand side by using TCP port 4444. And the blaster worm code will instruct the shell code to launch a TFTP client. And at the left-hand side, it also launch a TFTP server, so that the left-hand side, which is the attacker, and the right-hand side, which is the victim, they can download, or they can download a file, which is the MS Blast, this one, to the right-hand side, which is right here. And after that, the attacker will instruct the victim to execute the msblast.exe file. So from now on, the victim becomes a new attacker. And then so on and so forth, so on and so forth, so on and so forth. Because every computer in early 2000, they all have RPC, this vulnerable RPC services. So the MS Blast, the blaster won't, it propagate itself in just very few days, and thousands, I think is thousands or millions of Windows PC has been infected by blaster, because all those process is automatically the attacker, the MS Blast will can automatically search vulnerable RPC services, and after that, the target host, the victim, will become a new infected host, and so on and so forth, so on and so forth. And we can see that there are several different actions has been done at the left hand side and at the right hand side, and also in the network. So if we have a proper monitoring mechanism at the left hand side, for example, to monitor the process in the operating system, so we can observe certain actions. For example, create several processes to establish TFTP server, to initiate a thread number 2 to do SYN flooding. We can set up several different monitors in the operating system to monitor what a process do to the operating system, or what files has been accessed, what socket has been opened, what network packet has been sent. And at the right hand side is the same. And also we can set up a network-based monitor so that we can observe all the packet transmitted from the left hand side to the right hand side, and vice versa, so that we use this where we can profile an attack in many different ways. At the left hand side, we can set up a monitor. At the right hand side, we set up another monitor. At the middle, we can set up a firewall or some intrusion detection system to monitor all the packets pass by, so that we can record everything about the blaster. So after that, we will obtain several different logs or packets, or even this exe file. We can analyze those packets, but analyze those data. But in early days, we rely on security expert to help us to analyze those different type of data, and it is somehow very difficult to analyze those data. So that is the reason why in this class we will use several different algorithms and artificial intelligence method to help us to analyze all the collected data that we can observe in an attack. Okay, so I think we can stop right here for the first hour. I think we introduced several concepts of security management, and we show you a real world example of malicious software. Good, that's it. That is the management part. And after that, next hour or next week, we will talk about how do we use different kind of algorithms or tools to analyze the information we can collect in an attack. Okay, that's all.